Let's look at verifying inverse functions. For example, let's determine whether f of x equal to 5 minus 2x and g of x is equal to 5 halves minus x over 2 are inverses of each other. Well, we have the following fact. The two functions f and g are inverses of each other if and only if both of the following compositions hold. Namely, when we compose f with g of any x in the domain of g, then we get back to x. And if we compose g with f at any x in the domain of f, we also get back to x. That is, the composition in either direction gets us back to x. So let's compute f of g of x for our situation here. This is equal to f of, and g of x is this 5 halves minus x over 2. And now to compute f at any input, we put this input in where we see x. That is, this is equal to 5 minus 2 times that entire input. And then distributing the minus 2 through, we have 5 minus 2 times 5 halves. And then minus 2 times negative x over 2, which is equal to 5 minus 5, and then plus 2x divided by 2. And 5 minus 5 is 0. And then these 2's will cancel, which sure enough leaves us with x. So this first composition property is satisfied. However, we have to make sure the second one is also satisfied. So let's compute g of f of x. This is equal to g of, and f of x is this 5 minus 2x. And then to evaluate g at any input, we take this input and we put it up here wherever we see an x. That is, this is equal to 5 halves minus this whole input, or 5 minus 2x, all divided by 2, which is equal to 5 halves minus, and then dividing both terms in the numerator by 2, and distributing our negative gives us 5 halves minus a minus 2x over 2, or a plus 2x over 2. And 5 halves minus 5 halves is 0. And then these 2's will cancel. And sure enough, we get x. So this second composition property is satisfied as well. So yes, f and g are inverses of each other. That is, we can say that f is equal to g inverse, and g is equal to f inverse. All right, let's look at another example. Let's determine whether these two functions are inverses of each other. Again, we're going to compute both of these compositions and see if they yield x. So let's start with f of g of x. This is equal to f of negative 4 over x, because g of x is equal to negative 4 over x. And then f of any input, we put that input in wherever we see an x. That is, this is equal to 4 divided by negative 4 divided by x, which is 4 times x divided by negative 4. And then the 4's will cancel. However, we're still left with a negative 1 in the denominator, which means this is equal to negative x. It's not equal to x. So this is not satisfied. So these will not be inverses of each other. But let's, for the fun of it, compute the composition in the other direction. This is g of 4 divided by x, because f is 4 divided by x. And to compute g at any input, we take that input and plug it in wherever we see an x here. That is, this is equal to negative 4 divided by 4 over x, which is equal to negative 4 times x divided by 4. And again, these 4's will cancel, which leaves us with negative x, which again is not equal to x. So the second composition down here is also not satisfied. Now be careful here. Some students will think that because this composition down here, namely G composed with F, and this composition up here, namely F composed with G, are equal to one another, that these functions would be inverses of each other. But they're not, because not only do these compositions have to be equal to one another, they also have to be equal to x, not negative x. So our answer here then would be no, they're not inverses. All right, and this is how we verify whether two functions are inverses of one another. Thank you, and we'll see you next time.